This is just a continuation of what we started in class a couple days ago with evaluating limits analytically. We started with just plain direct substitution, where you just try to simply substitute the number in and get an output. But that didn't work most of the time. In fact, most of the time, whenever you substituted the number in, we got a zero denominator. So another technique that we looked at was using factoring, officially called the cancellation technique. You would factor it and hope that one of the factors would cancel out, and you'd be able to do direct substitution to finish it. That's not always going to work either, especially if you don't have anything to factor. There is one last technique that we can do called the conjugate method, or the rationalization technique, and that's the one we'll focus on right now. Before we begin with calculus, let's go all the way back to algebra and think about where you saw rationalization in the past. When you had a fraction with an irrational denominator, we used a technique called rationalizing the denominator to try to remove that. It was all part of the simplification process. So if you remember correctly, in the first one, even though 3 over root 2 is a valid answer, it's not considered simplified. And the technique we used to get rid of it was to multiply the numerator and denominator by root 2. Multiplying across the top, we'd get 3 root 2, and across the bottom, a root multiplied by itself, you just get what's inside, which is 2. Even though this is more stuff, more numbers, it's considered simplified because it's rationalized. Okay, but think about the next one. This one's a little bit more challenging. We can't actually do just multiply by root 2 over root 2. It doesn't work now. In this one, we used an idea called the conjugate. The conjugate is whenever you multiply by that root and you change the symbol in between. So like on this one, it would be root 2 plus 1. This is going to be a lot more work. So let's see. In the numerator, nothing can really be done. I'm just going to rewrite it as 3 times root 2 plus 1. But in the denominator, when you multiply by the conjugate, some special things happen. So think about down here. This is going to be the FOIL technique. You have a binomial times a binomial. The first term's root 2 times root 2. The number by itself gives me a plain 2. The outsides and the insides actually cancel each other out. We'll have a root 2 plus a negative root 2. That's always going to happen. In fact, when you use conjugates, if that doesn't happen, you've done something wrong. Okay, conjugates, when you FOIL, the outer and inner terms will cancel every single time. But then we do have to do the last. The last terms would be minus 1 times a positive 1, or negative 1. This is going to simplify even more. I'm going to leave the numerator alone, and you can see in this case the denominator is just a 1. You really didn't have to write it. The key thing is there's no irrational numbers in the denominator, so it's considered more simplified. This whole idea of using a conjugate to rationalize is exactly what we're going to do to find a limit. It's just going to be for a totally different purpose, what we're going to do in our class. We are going to look at 2 separate examples of how the rationalization technique works. So the first thing we want to do is try direct substitution. And you can see just by inspection that if you try direct substitution, you get a 0 denominator, which is what we're trying to avoid. So I'm going to go ahead and try to rationalize. Now here, something interesting right away. The denominator does not contain a root. And I want to emphasize, we're using rationalization and the conjugate for a totally different purpose. So I'm still going to multiply by the conjugate. It's just, in this case, it's going to be in the numerator. So let me multiply the numerator by x plus 1, and then changing the sign, plus 1. The numerator is going to be somewhat of a mess, to be honest, just to FOIL and to get together. So let me go ahead and start that. In the numerator, we need to FOIL. I'm going to do the square root of x plus 1 times the square root of x plus 1. Multiplying by itself, we'll just get x plus 1. Just like mentioning before, the outsides and the insides should cancel each other out, and they do. The square root of x plus 1 and minus the square root of x plus 1 are going to go away, so I'm not even going to write them on there. The last terms, negative 1 times positive 1, will just be a negative 1. The denominator is even a bigger mess, but in this case, I'm just going to leave it go. We have an x on the outside and then that square root of x plus 1 plus 1. You'll see later on here in our work why that's important to leave alone. The rest is simplification. Direct substitution still doesn't work. Instead, what I want to do is simplify as much as possible with algebra. In the numerator, the 1's will cancel. And then hopefully at this point you can see why we left that alone. The x's now cancel, leaving a 1 when it's reduced. Now I still haven't used direct substitution, so I'm going to go ahead and write that limit symbol again with the 1 in the numerator, and then the square root of x plus 1 plus 1. Again, I want to emphasize that whole idea of rationalizing doesn't seem to make sense here that we talked about in algebra. I'm actually put a root in the denominator. But the key thing is you want to keep going and attempt direct substitution. It doesn't matter. We're simplifying completely with a number. So I'm going to try to put 0 in, which should work this time. We get 1 over the square root of 1 plus 1, which is a half. That's the intended height of this function. Let's look at another one. In this next example, we're going to take the limit as x approaches 3. And again, by inspection, you can see that that's going to produce a 0 denominator. So I'm going to start right away by multiplying by the conjugate. Right, so in this one, the conjugate will be the square root of x plus 1 plus 2. All right, so lots of multiplication and FOIL. In this one, I'm going to take the first terms, which is the square root of x plus 1 times itself, or just x plus 1. The outsides and insides are going to cancel each other out, just like we had planned for. And then finally, the last, negative 2 times positive 2, will be a minus 4. The denominator is kind of an even bigger mess again. I don't want to do anything with it though. Let me just recopy it. We have x minus 3 from the first denominator, and that's being multiplied by this conjugate, square root of x plus 1 plus 2. Let's do some algebra to get this even further simplified, because at this point direct substitution still fails. In the numerator, we don't get cancellation, but there is some simplification. The 1 minus 4 turns into a negative 3. You might see already what's going on. Now, the x minus 3's actually cancel. They reduce to 1. And we're left with 1 all divided by the square root of x plus 1 plus 2. By completing direct substitution, I'm going to get 1 all over the square root of 4 plus 2, which is a fourth.